Hey everyone, and welcome to This Explainer. I am absolutely thrilled to have you here with us today. We're going to jump right in because today we are shining a massive spotlight on the unseen and honestly, often completely ignored foundations of artificial intelligence. We hear a ton about AI outputs, right? The amazing images, the poetry, the incredibly fast code these models can generate. But today, we're looking at the inputs. We are looking at the foundation itself. Because right now, there is a massive shift happening in how we build these systems, and it all comes down to what we're actually feeding them. So let's dive into this. Remove, data's, trail, and watch what follows. I really want you to think about that for a second. We're talking about the ultimate black box here. We feed information in, we get answers out, but what happens in the middle? It's completely opaque. When we strip away the history of where our information actually comes from, we aren't just cleaning up code to make it run faster. No, we're literally blinding the machine to the reality of the world it's supposed to understand. Direction disappears. Take a moment and just let the gravity of that statement sink in. Without a trail, the data has absolutely no compass. It doesn't know where it came from, under what conditions it was gathered, or who even created it. And when direction disappears, everything built on top of it just starts to drift. Think about it. Without a compass, an AI might combine a highly factual, peer-reviewed scientific paper with, say, a satirical blog post, completely unable to tell the difference between the two. The distinction is just lost.
All right, section 1, when data loses its trail.
This is the moment decisions entirely lose their foundation. Suddenly, systems that looked completely reliable start producing outputs that nobody can explain. I like to think of this as the amnesia metaphor. Imagine a brilliant world-class scholar who suddenly loses all their memories. They might still know how to speak right, they might still process information exceptionally well, and they might give you an answer that sounds perfectly eloquent and super confident. But because they can't remember where they learned the facts or what experiences actually shaped their worldview, their core judgment is just gone. The answer is completely unreliable. And guys, that is exactly what happens to an AI system when its data forgets its own past.
Now, what's really interesting about this slide is the question it poses. What happens when data loses its provenance? When provenance, which is just a fancy word for the verifiable origin story of data, when that's lost, it forces us to look past the shiny, user-friendly interface of our AI tools and really peer into the messy machinery underneath. The consequences of losing this origin story are severe. When the system doesn't know the who, what, when, and where of its training material, it literally cannot properly weigh the value of that material. Let's look at exactly how that plays out in the actual data pipeline. Which brings us to section 2, the cost of stripped context. So this breakdown happens in 3 distinct, really violent separations during typical data gathering, like mass web scraping. First, labels get stripped. When developers scrape millions of data points off the internet to feed a hungry model, the essential tags that tell a system what it's looking at often get totally torn away, just for the sake of volume and speed. Second, context gets separated from content. The why and the how are completely divorced from the what. A paragraph of text is just text. Actually, scratch that. It's just raw data without a soul. The nuance of whether it was a joke, a legal ruling, or just someone's opinion is totally gone. And finally, the record of how that information was produced simply dissolves into the pipeline. Look, this isn't just a harmless glitch. When these elements are separated, the data loses its tether to reality. And this introduces a massive, massive risk. Because that record dissolved, what arrives at the other end of the pipeline cannot be verified. It can only be accepted. You are forced to blindly trust the machine. Without a trail, there's no audit. There's no double checking. You are entirely at the mercy of unverified outputs. Now, if you're using AI to generate a quick recipe for dinner, okay, maybe that's fine. But if you're using AI for legal research, financial modeling, or medical diagnostics, crossing your fingers simply isn't an option. You absolutely cannot afford an unverified hallucination. Okay, let's flip the script. Section 3, rebuilding from the record.
To understand this structured fix for all this chaos, we really need to clearly define the core mechanic we're using. We are talking about data provenance, specifically secured through on-chain history. Think of on-chain like a permanent digital receipt, using blockchain technology that cannot be altered, spoofed, or erased. It is the traceable story and verified origin of information. It means data isn't just a random floating number in a server somewhere anymore. It's a permanent artifact with a clear, undeniable history securely attached to it. And this is exactly where Codata comes in. Rather than trying to patch a broken pipeline at the very end when the damage is already done, Codata provides a structural protocol at the very beginning. They rebuild from the record up. So the crucial point is that they treat the data like a meticulously constructed building. Before a single piece of the structure goes up, they make absolutely sure the ground underneath it is certified, mapped, and mathematically secure. Here are the 3 precise mechanics of how Codata actually pulls this off. Step 1. Every single dataset gets constructed with its origin fully intact. The source is known and heavily logged. Step 2. Every single label gets verified, ensuring human-level accuracy and preventing that stripped context we talked about earlier. And Step 3. Every piece goes on-chain with its history permanently attached. Through cryptographic proof, this history becomes immutable. What this means is that the data entering a machine learning model now carries a traceable, verifiable story. It's not just an empty value anymore. It's a discrete piece of intelligence with a known, provable past. Let's bring this all together in Section 4, Noise versus Trusted Intelligence. And this brilliantly illustrates the massive contrast we're dealing with. On one side, we have data as noise, inputs that are not understood, resting on a terribly weak foundation. When you feed an AI noise, you spend literally all your time trying to filter out the hallucinations and errors. But on the other side, we have data as trusted intelligence, inputs that are deeply understood, built on a rock-solid, verifiable foundation. When AI is trained on data with this kind of integrity, it performs with an entirely different, vastly superior quality. The machine isn't guessing anymore, guys. It's computing based on reality. An AI built this way makes decisions that actually hold up. Why? Because the foundation they were built on was solid. It understands because the inputs it learned from were understood. That's the whole blueprint motif coming full circle. You cannot build a skyscraper on quicksand, and you absolutely cannot build reliable, enterprise-grade artificial intelligence on unverified amnesiac data. The record matters, the origin matters. Without it, you just have a very fast machine making very fast mistakes. So, I want to leave you with a question to deeply consider the next time you use any intelligence system. Look past the answer it gives you, look past the shiny interface, and ask yourself about the foundation of that answer. Does your AI rely on noise or trusted intelligence? Thank you so much for joining me for this explainer. Stay curious, keep looking at those foundations, and I'll catch you next time.